Hey guys, it's your boy Matty P and welcome back to another video. Today's video is very different. It's not a hiking video or a support video. It's a math video. And while that might sound a bit daunting or boring, you think, oh, math. Math is incredibly useful and interesting. It's applied in almost every discipline, whether it be scientific or engineering or construction related or financial. Maths is needed for everything. Basically, it's the backbone of the sciences and, well, basically everything else. Now, math can actually be really interesting when it's taught right. So, today I want to just give you an introduction of math. So, as you can see, I've drawn a world map here. It's not very good. There's Europe, the Middle East, Africa, South America, the United States. Oh, I guess I forgot Australia, but we don't need Australia today. So I'll start in Africa. Now, around Central Africa and such, and Egypt, I think maybe the Ethiopians might have discovered some maths as well. They were trying to measure time, doing counting, sequences. So the very basics of maths originated right here and here. But there's not enough to really go into this, so we'll move on to the Southern Europe and the Middle East. Now, this is where it gets interesting. We have a guy named Pythagoras. Now, Pythagoras created the theorem a squared plus b squared equals c squared, which means on a triangle you have sides a, b, and c. It says, and so that's the hypotenuse, the opposite, and the adjacent. All this is really is just saying that this is equal to the square of this is equal to the sum of the squares of the other two sides. But that's incredibly useful because we can find basically any side using that information. Now, around the Middle East and Southern Europe, there were also other significant contributions to geometry as well, such as trigonometry and the basic trigonometric functions. But we'll talk about that later. So now we have around more Northern Europe, you could say. Just rub out Pythagoras. We have a bunch of different folks here. So we have, my name's Isaac. Looks like my pen's running out of ink. Newton. He's around there. And William Leibniz. Now, these two were mathematicians that made significant contributions to calculus, and calculus, if you don't know, is a study of rates of change, and it's really, really useful. So Newton was also a very well-known physicist, whereas William Leibniz was more interested in engineering and the study of the calculus of infinitesimals, or infinitely small numbers. So these two were very influential. Calculus had been done before by Greeks and Romans, but they really just expanded it. Basically, the foundation, like the concrete foundation was there, but they really paved the bricks and painted the house for it, if you get what I'm saying. Now, we also have another guy called Leonhard Euler. Euler was known for discovering pi. I mean, they'd still been able to calculate area of circles before, but Euler made it official. And he also made the imaginary unit official, which solved the problem with this for the square roots of negative numbers. So all these guys really made a huge contribution to maths. Now we'll move on to the United States. Now we have a guy, I think his name's Maginot or something, I can't pronounce it very well, but he made significant contributions to number theory, and there was Hilbert as well. Now, what Hilbert did was quite special. Hilbert was an American mathematician who made contributions and laid the groundwork for topology. Now, topology is the only discipline of maths that hadn't been anticipated by ancient mathematicians and medieval mathematicians as well. Now, topology is really useful. There's many applications in physics, in maths, in chemistry. They're all really interrelated, these disciplines now. I'll just show you some basics of maths. So I'll just rub that out. So we'll start with algebra. Because algebra is it's been called the unifying thread of maths, but all algebra really is just, the skeleton of maths, really, you could say. So some basics of algebra are variables such as x, y, z, and here is polynomial ax squared plus bx plus c. So polynomials are really important. Polynomials are crucial to algebra, calculus, and algebraic geometry. And these variables can also be added if you're, say, using like terms. You just sort out the like terms here. When that would just be negative xy plus 3z. Now, I want to show you something else, since this is also really important. Now, if you want to find the formula for the variable x of this equation, polynomial, all you have to do is just use this simple formula, which is negative b plus or minus the square root of b squared minus 4ac divided by 2a. And there you go, there you have it. That, folks, is the quadratic formula. Yeah, there we have it. Quadratic formula. Just see if you can see it. This next one I'm going to cover is geometry. So, geometry. Jeez, my pen has really run out of ink. Sorry, guys. So, geometry. Geometry is the study of shapes, spaces, and the like. It's quite interrelated with algebra and topology. Now, I'll cover something called trigonometry. And really all trigonometry is just the study of triangles, and you'll realise why it's so important when you delve into it later, and calculus as well. So here we have a triangle with sides A, B, I'll just label that actually O, A, and H. Now what's really important, and you may have covered this in high school, is the trigonometric functions, and sine, cosine, and tangent, or SOHCAHTOA. And the sine is just the ratio, it's just the opposite over the hypotenuse. So just this side over this side, the ratio of that. Now the cosine is just the adjacent over the hypotenuse, so that's just the ratio of this side over this side. And the tangent here is just the opposite over the adjacent, or side over this side. Now there are other functions such as the reciprocal and inverse trigonometric functions, but we'll cover that later. So now, you know, the fundamentals of trigonometry, which is a very, very important field in maths. They're all really important, but trigonometry is, it's a huge aid in some other fields of maths, such as calculus. I find the trig angle identities will help you with that. And now I'll do a bit of number theory, or I suppose you could say algebra. Oh, actually, sorry, we might as well mention pi. Now, pi is really important because pi times the radius squared gives you the area of a circle. Pi is really important in circle functions, and etc. And there's a bunch of different formulas for circles and cylindrical shapes and the like using it. But back to what I was saying before. So here's a bit of a dilemma for you. What is the square root of -1? You probably don't have an answer to it. And what we use to solve it is just this number called the imaginary unit, or I. So I squared equals -1. Now I to the power of 3 equals just -I. And I to the power of 4 is just -1. And so on. Now, what's also really important is our applications with complex numbers and roots of polynomials, quadratic polynomials. And the fundamental theorem of algebra states that every quadratic polynomial must contain at least one complex root. But now I'll show you what a complex number is. A complex number is any number of the form a plus bi. Now, and that means a is the real part, so for example 2 plus the imaginary part, 3i, because you can have imaginary numbers. And this is incredibly useful. This has many applications in electrical engineering and etc. And it's just such a solution to the problem, the square root of negative numbers. And they have their own plane as well, a complex plane and complex functions, etc. Now, my favourite, we'll do a bit of calculus. So all calculus is just the study of rates of change. And one of the basics of calculus is limits. Limits. So say I have 3, 2, 1, and 1, 2, 3. Now say if my function, as x approaches 2, the value starts to approach 3, then we would just set a limit as 3. Now, what if, as the limit approaches 3, as x approaches 3, y begins to approach infinity? Well, that's just a limit at infinity. And now, last but not least, we have, just finish erasing the whiteboard, derivatives. Now, all a derivative is really is just the rate of change of a variable with respect for another variable. So it could be x, y, z, w if you're doing it in more than 3 dimensions. And the formal definition of a derivative is as the limit approaches, as x approaches 0 of the function x plus change in x minus the function of x divided by x plus change in x minus x. And there you have it. That's the whole definition of a limit. The derivative, sorry. Now, there are many derivative rules. One such rule is a power rule, and they're used to calculating this. What's really important about this is that you can calculate the gradient or slope. You might have done gradients of lines in high school, but you can also calculate the gradient on the slope of a curve. So the power rule just says that, say I have the number, oh geez, my pen's really running out of ink. Let's see if I've got a pen or something here. Might give it another try. So say I have the number, see if you can read this. Say I have the number x to the power of n. Basically what it is, say if I have the number, say if I have x to the power of the variable n, or x to the power of 2, then all we're going to do, x to the power of 3. Now to find the slope of that function, all you would do is times the number by the exponent, and then change the exponent to that number minus 1. So say then the polynomial x to the power of 3 minus 5x to the power of 2 plus 1, the slope of that, and we cancel out the constant at the end, is just going to be, I'm correct, I said, sorry, I'm a bit forgetful, guys, it was x to the power of 3 plus 5 of x to the power of 2. That would just be 3x to the power of 2 plus 10x. And that's actually really useful. Now, there are many other derivative rules that I'll cover in later videos. So those are the 4 basic disciplines of math: calculus, number theory, algebra, and geometry. And there's also other ones like combinatorics, topology, etc., where you'll deal with topological spaces, and permutations and combinations. The permutation is really just I'm saying this just because I can't write it. A permutation is just a number of different arrangements you can have of something. A combination is just the number of different selections of that something that you can have. So while order does matter for permutations, it doesn't matter for combinations. And factorials, which is just a number times all the numbers less than it, are really important for this. Now, I hope you guys enjoyed my video. I hope it helped you a bit, gave you an introduction to maths. Maths gets way more interesting as you delve deeper in it. It's incredibly useful. I'm so glad I've been studying it. I've really learned a lot from it. It has many applications. Even if you don't like maths, so you're not so much interested in maths, but interested in physics, chemistry, biology, engineering, medicine, construction, finance. Maths has applications in all of those. And yeah, I really hope you guys enjoyed my video, and I hope you have a great day.